Hello folks, Bubble here, Arcane Devices. Today I'd like to try to make a little bit of a prototype with our CaseLink interface, which is this, which is what this port here is for. It's basically a SATA compatible port. Well, I'm not gonna say it's SATA because it's definitely not. I mean, you can plug hard drive here, and like, even if you could, I believe it's a trademark. So it's not SATA. It's Arcane Devices CaseLink. It's our proprietary, let's say, interface for connecting expanders to our awesome CoS of stars sequencer. Now, basically this is gonna use UART most likely, because that's what this SAMD microcontroller can do, and this basically has two lanes: transmit and receive, and both are differential. So we have those. Well, let me see if I can get a little bit better light here. So on the logic board of the CoS, there is a transmitter and a receiver chip between the microcontroller and the connector here, and those are LVDS transmitter, and there are an LVDS transmitter and an LVDS receiver. I also have this proto board here that has a 2-channel LVDS transceiver. So it has 2 receivers and 2 transmitters. And we can use that to build some kind of a prototype for an expander. That's pretty much the idea. The original or the earlier version of the CoS logic board had the same chip on it, but just to optimize things, we moved on to two separate smaller chips, and they seem to do their work just fine. I already kind of tested this this setup just by doing a loopback, so transmitting from CoS to here, and then just connecting the receive and transmit side, single-ended on the single-ended side, just so the received data gets looped back. So it is as transmitters and receivers, they basically convert 3.3 volt single-ended logic signal into a differential LVDS signal, which is low voltage differential signaling, which basically has quite a smaller level in terms of voltage, and you're supposed to have a 100 ohm termination on the receiver side. And we did that mostly to reduce noise, like any EMI emissions. And also the SATA cables are shielded, so in addition to being differential, which by itself makes it much less prone to emission and to noise. Into interference. And also I can go pretty fast, like much faster than the UART. And here you can do, like with this UART, you can do like 6 megabit per second, or megabaud, roughly. You can make it transmit faster, but I don't think the SAMD can decode faster, because just because of how the clock recovery works. If you had a separate clock signal, you could go faster easily over a link like that, but since there is only one receive and one transmit line, you have to embed the clock information into the signal. Right? Okay, so reminder to go to arcane.audio and pre-order the CoS, of course. Anyway, so I tested this setup with a loopback. Now I'd like to start prototyping on some kind of an expander, and probably use one of the boards I have. So I have a couple of different microcontroller boards here. What's that? Oh, there's a Bluetooth one. I like those Zhao, Siduino Zhao. I don't know that's the correct Chinese pronunciation. But anyway, this have a SAMD 21, which is slower than the 51 that I have on the CoS, and that will probably be able to receive at like 3 megabits a second, if it can do that. I don't remember if it has crystal on it. So there is this one, and there is one from Adafruit that's based on this. Cutie Pie, I think it's called. One of them have a crystal and the other doesn't, but I never remember which one is which. Anyway, even if this doesn't work at high speed, we can still get something done. And maybe we'll move to SAMD 51 for an actual build. I also have a SAMD 51 Metro board from Adafruit, but it's kind of busted. And also, if I could make it work with the small one, we could possibly. I can imagine we could make an actual module out of that. Just some kind of protoboard. Okay. So I'm gonna start by plopping this into my breadboard here. But let's see how far we can get. Okay, so gonna need. I think I'm gonna need another USB-C cable. Let me see if I can find one. Also, I had quite a bunch of those gel boards, but a lot of them got busted when I was building various prototypes. So yeah, I don't know if I will find a working one. Hopefully, let's see. So I get some USB cables here. Let's see if this one works. Oh shit. Yeah. I want this here definitely. Actually, I'll make this big for you. There we go. Wait, I did make it, but just the. Come on. Oh yeah, we have a CD now. Nice. Nice. Okay, so I'll now start with a new sketch. We're gonna do some Arduino just for the prototype's sake. Since it's kind of easy to set up a serial. And I don't remember, there's I think there's a serial 1 and a serial USB, right? What was it, setup? No. Begin probably. And I'm gonna want to have a baud right here. Oh, what was it? Just 1,000? 1 million? Oh, that's supposed to be a multiple something of something. Let's just try 1 megabaud for starters. Gonna see how that works. And let's just start by transmitting something. Okay, let's try loading. Let's try loading that in. Ah, it didn't erase. Let's see what's happening here. Yeah, this might be a busted board. Let's just try again, see if that does anything. So there is a way to force reset on here. Yeah, by shorting the paths. Let me get it here so that you can see. Okay, did that do anything? Yeah, I see an Arduino drive. Okay. Yeah, I'm having a lot of issues with Arduino uploading sketches. See, did that work or not? Oh yeah, verify successful, okay. So it tends to fail in like every other time I try to upload a sketch. And I don't know if it's an issue with my Mac or... So I thought that's just a bad board, but looks like this has the same issue, so... Yeah, anyway, let's see if this is transmitting. So there was a TX somewhere on one of those output pins. I'm gonna have to find it first. Let's grab a ground. So this one here. Actually, we can make it shorter. Remember, I try to keep your loops as short as possible when probing. Oh yeah, let's get to... I think it was one of the edges. This should be VCC. Oh, we don't have. We need to set the triggering first, maybe? No. Yeah, triggering. This is. Oh, yeah, I need to be at timestamp. No, sorry, wrong channel. The probe is here. Okay, this should work. Okay, looks like we've got a signal. Yeah, how about this? Let's get this a bit higher. Something like that, maybe. Okay, so the TX is here. Let's zoom in a bit. Is this actually at 1 megabaud? Let's see, measure frequency. So I expect to see 500 kilohertz for about 1 megabaud. And yeah, so yeah, we have something around that. Can also try to measure this with a cursor. Okay, so it's I would see that it's like 1 microsecond. So we are at microsecond per division. And yeah, that checks out. So I believe the receive was like either here or next to on that side. Let me find a pinout. I should have one saved somewhere. Okay, so that's the schematic. That works too. There were some nice pinout pictures, but we can find out from here. Okay, so yeah, and TX is on here and receive is on the opposite side. Okay, just as I thought. And do we have 3.3 volts here? Yes, we do. So actually I'm gonna want to steal this voltage. I'm not gonna need this regulator anymore. And what's going on here? So this was expecting 3.3 volts, I think. Grab some more wires. Which apparently were on the floor. So of course this will be awful for signal integrity. But there is a chance it will be good enough for what we're trying to do. So I think this was supposed to be ground. Let's check what the cap says. negative here. And 3.3. It's gonna go here. Oh, it's still good. Yes. Yeah, so I have already I have a setup receptacle kind of soldered here. In this messy way. I had it on a proto PCB, but actually this shit is soldering somehow works better. Yeah, so those are designed for like much higher bandwidth than what we're gonna work with. Like the SATA cable that can work with, you know, gigahertz, like multiples of gigahertz. And we are like, you know, if we can get 6 megabits per second, that's gonna be good for our purposes. This step will need to be in here. Oh yeah, I was just trying to figure out what the connections here are messed up, but it's just probably because I was setting the loopback like that. Okay, so the chip is an LVD 30550, I believe. Let's see the docs. So those, wait, which is, yeah, that's the one. Okay, so it's LVDS 050, okay. Sure. So this corner is gonna be the VCC here, right? So it has the pin 1 marker on this side. This is gonna be a ground, which is of course way too long for signal integrity. Yeah, what I want to know is where my differential input and outputs are supposed to go on this edge here, which is this. Okay, so A, B are the inputs. Okay. Now, if only I remembered which way the transmit and receive go. I think I need to Google. Okay. Let me grab a fresh Chrome. Yeah, which is transmit and which is receive. Or are they not marked like that? Yeah, I mean it would make sense if it's just AB, I suppose. Okay. Here. So the keyed side has receive pins. Okay. Which is here. It's the ground. Okay, so that one I think I have connected correctly. So now let's find the transmit pins. Wait, do they need to go over on this side? So those are all inputs. And all the outputs, the differential outputs, are here. Okay. I suppose we can try to make it work. If I break those wires, that's like over. Because this connector is already pretty tortured. And you're telling me I have to bring it all the way to here. Yeah, no, that's right. Likewise, the wire here. Yeah, okay, so this should go to transmit. Which was here, right? Yes. So let's try to actually connect it up here first. So I'm gonna take the input to the driver and connect that to my transmit outputs from the micro. This is still too short. Yeah, I guess I could move the board closer, but I need to reconnect all this stuff here. And honestly, that might not be necessary. Let's see. Okay, so that should be transmitting on the differential, the outputs here. Okay. And this, though I'm not sure why this is 3.3, maybe that's because those are unloaded. Let's double check. So this is VCC, sure. Yeah, it's there. Then is my single-ended input. Yep. And then the two differential outputs. So the outputs should go to this connector here. Let's see if we can manage to set it up without breaking the connector. I'm not really paying attention to which is positive and which is negative yet, because if I get it wrong, then yeah, there it is, broken. Because if I get it wrong, I can just flip it. So that is something, but of course I'm going to fix this. At least we can check if we are getting output it's broken. Those are received, which we didn't do anything about yet. Now, unfortunately, like soldering to this connector is a huge pain, so could I make a decent breakout board for this? Yeah, I suppose I should have, but I didn't, so we're gonna need to improvise. Oh yeah, I don't need the power supply here either. Actually, I wonder, does this tell me the voltage? No. Okay, so let's take this all out again. That's gonna be a bit of a pain in the ass. I don't know if we can make it work this time without destroying this connector. Let's give it a bit of flux. Could have gone with a smaller tip for this one actually. get it? Let's show you that I shot it. Let's check. Continuity. Yeah, shot it. Okay, and now let's shot it to the ground. Oh, did I get it? Wait, how? Oh. Yeah. Right. Okay, so looks like we've got it. Let's hope it doesn't fall apart. Yeah, it's already dead. I'm surprised it was the crappiest soldering job ever. Some more solder on here. Of course. did something. And it fell off. Or is that a different one? Interesting. So I've got some vertical receptacles as well. Maybe this will be easier to work with. Probably not. Maybe I can do it in place. Let's see. Can I solder this in place? Without making a giant mess. Also, let's bring the mic closer so that you can hear me. My yapping. Okay, that's gonna be crazy if this actually works. Okay, that looks kinda soldered. Good. So the next thing I'm gonna want to do is make the actual CoS send some data over the port, and we're gonna see if this contraption can pick it up and read it correctly. So I'm gonna need one more wire here. Actually, let's maybe steal something from here. No, still too short. Yeah, so that should be our Rx. Now there are two options. I either get the polarity right, or I flipped it. I'm gonna see in a sec. But first, we're gonna need to do some coding. So let's get back to the computer. Oh yeah, I suppose I was talking about those pinouts without actually showing you the PDF, was I? Yeah, streaming. I have no idea what I'm doing. Anyway, back to code. So I suppose we're gonna need a new thread. Okay, so let's make one. Yeah, let's allocate stack, and that's gonna be, let's call this X. Maybe let's call the thread link. See, I don't remember if there's a default baud set. Probably there was. Okay, so is it a ring buffer? Oh, actually it doesn't matter. All I want to do is write yeah, no, it's been, I think it's blocking. Anyway, we'll see what happens. Let's see, we're gonna repeat every 10 ticks, which should be millisecond, I think, if I remember correctly. Okay, so are we transmitting anything? Oh crap. Alright, did we fry something? Why is this suddenly taking so much current? So yeah, getting overcurrent on the power supply here for some reason. Hey, did I just short something here? That's possible. Sorry. Let's see if I can get. Oh, so those are. Yeah, I have some older boards here, and yeah, you can see this. Just have this TI LVDS chip. I mean, actually, the new ones are TI too. Anyway, yeah, there is this LVDS 050 here. I can try running that. I can try running this board. Perhaps. And yeah, no. I should have some more. No idea what happened with that one, to be honest. They don't have overcurrent protection built in, so it shouldn't be possible to break that easily. How about this one? Let's be more careful this time. Okay, yeah, this is transmitting. That's good. So let's grab some cables. I have some brand new ones here. Let's see if it's any good. They look pretty solid. How do we want to do this? Okay, let's try plopping that one here. And then here, I suppose. Okay. And let's see if we get anything on this side. Oh yeah, appears that we do. Wait. Now it's gone. What's happening here? Okay, I don't know. I don't know, man. So there was an enable pin that needed to be pulled on that driver, but I think I already have all of those connected. So there's a drive enable and a receive enable, I think. So RE is 4, pin 4. Let's see. Wait. Okay, so it's not receive enable. What is that trash? Nah, that's just nice. Where's that coming from? Let's check this. Let's try to check this source again. Oh, okay, so there's my transmission. Okay, so this is what should be going out. And that's the inverted side. Okay, so we are sending something. Next question is that cable any good? This is kind of a pain to probe. Sure, it's here. Okay, so that is fine, and it's on my right side here. I mean the output is. It should be fine. Okay, so let's see that again. Ground. And nothing here. So what gives? Just noise. Ah, right. That's why this were here, because this actually needs a 100 ohm termination, which is not in that chip. Oh man. Oh, I'm an idiot. Of course. That's why I had those resistors here. Which I hope are actually 50 ohm, since they were here. Still looks like nice though. So at least this is at steady level, which is what should happen if the signal is balanced. But what is this crap? Ah. Okay, so there's a chance we just busted this connector. Where did that other one go? Yeah, so signals here. It's just this is broken. Didn't it? I continue to check just a second ago. Okay, so I shorted that. Okay. Yeah, there's a short here. Looks like this could be fixed mechanically. Maybe. Wait, no. I thought I saw it, but I don't anymore. Did it just break apart? And now still short. Now this could actually be a little bit easier to solder to. And also I kinda need thinner wire. Alright, so I don't really know where my thin wire went, unfortunately. But I found one of those old boards. It's unpopulated, except from the port. So actually, what I think I'm gonna do is just solder the wire onto the board here. It's good. That should be easier than, trying to solder directly to the port. Alright, let's give that a shot. And I found the thin wire. It was here all along, of course. Of course. That's how it is. Oh, I know why I used the thick one. Because this is a bit fickle when I try to put it on the breadboard. But it's possible, I guess. I suppose. We'll see. About this long. did the other two go? And yeah, that's much easier than trying to get that board. The heck? Oh, right. Oh, come on. Yeah, of course it turned off on me. Of course. Oh, what the heck? Okay, so looks like it's those two here. And the opposite of where I soldered, so yeah, it's not gonna be the most easy place to solder onto, but should be doable. Wire. More wire. Okay, and we're gonna need ground as well. But for that, I'm just gonna solder to one of the easy spots. This should work. Again, not caring about loop size that much right now. Right, ground planes. Yeah, let them heat up a bit. It's not soldered at all. Ground planes. This board has two inner ground plane layers, so you know. Okay, let's try here. This pad might be a bit easier. No. Still no. Let's do higher temp. Looks awful, but might work. Okay, so let's grab our transmitter here. Yeah, maybe it would be a good idea to actually run the program. Okay, yeah, there we have it. Now let's try to put that together with our receiver here. Again, which side is positive and which side is negative? Yes. further down. And the moment of truth. Yeah, I think it's flipped. It should be normally high, and we get normally low here. Yep, there we go. And what about this? Hard to say. Either way, let's see if we can actually receive something now. Read. Okay, so that reads an end. Let's disable the transmit for now. Yeah, let's printf. How is that? Why no port? Huh? Ah, yeah. Screen. Again. Oh yeah, so I just added those two lines here. Read from serial and print. Now, oh yeah, and we still don't know if we are on the right baud rate, which we're probably not. So let's try to measure that. Actually, we are. It appears that we are. That would be nice. I didn't actually expect that. But that would help for sure. Okay, so what's up with the serial part though? Ah, okay. There it is. I want an unsigned and actually let's print hex. Right, so looks like it gets some of them right. And a lot of garbage. Oh, does it? Ah, maybe it just returns -1 if there's no data. Okay, let's see. Serial available. Oh, come on. I don't need your braces. There we are. Zeros and A's. So, if you don't remember or haven't seen the previous part, write a little thread for the CoS that's doing the transmitting here, and that's exactly what we are sending, a 0 and an AA. So that works perfectly. Awesome, man. Awesome. Okay, so that's gonna be it for today. So we get part 1, and then we get some kind of receiver going on here. You know what? If I wasn't an idiot, I would actually put the chip on its footprint here instead of this mess. Well, at least maybe we can reuse the connector that way if we need to. Anyway, so we've got that talking to the to the little Arduino board. That's what the Arduino code is running on. Right, we get that receiving through the LVDS transceiver, through the SATA port, the SATA cable that goes to the transmitter and receiver on the CoS, and that is then going to the SUMD51 on the CoS, which is sending our zeros and AAs. So yeah, pretty good so far. So if I gonna do another stream, we'll have this board actually do some kind of expander function. So we'll need to use the I/O here. So there's a single DAC and some other I/Os which we can use. We can actually probably use the PWM too for experiments. We probably need to put an op amp in front of this, since that's just 0 to 3.3 volts. Yeah, so we'll need to have some gain after that. Probably a filter if we'd like to do PWM. Yeah. And then we can actually have a working expander. right? And then we also, of course, need to modify the code on the CoS to deal with additional outputs, additional channels. That's probably gonna be the most challenging part, but we can get something started to prove the concept, right? I don't know if we can get this done in time from Brustronica. Probably not in any, sensible form. But I mean, it would do for a nice demo if we did. Okay, so thanks for watching, and see you next time. Again, come over to arcane.audio, support our Indiegogo. This is really the main part, the main thing of this is the whole thing, right? If we can make it to 10K, we'll be able to get it out, to get the module out to you. Okay, so I don't know if you can hear it, but it started to rain, so I can go chill now. Alright, cheers.